Welcome to another episode of Rusty Science. Today we are going to answer one of the important questions in the history of science. Do all our hopes of seeing live dinosaurs lost? Can we see live dinosaurs today? You need to watch till the end of this video to find out the answer. As title mentioned, can we see live dinosaurs today? Which obviously lived 250 million years ago on this earth. Is it possible to see today? No way, right? But I am bringing you a way that we can see live dinosaurs even today. Before we see how to see dinosaur, we need to see what is see or seeing. Seeing involves two major things. One is observer, another one is observable object, right? In this case, I am your observable object and you are the observer. Through this camera, obviously you are observing me, so you are the observer, I am the observing object. But we are missing one crucial part here, which is light. I will illustrate the behavior of light with this ping pong ball. When the ping pong ball hit on the wall and it get reflected and it reaches its destination, in that case it's a bin. Why it landed up in the bin? Because Earth has its gravity and it pulled the ball and it just fallen into the bin. But if you think about the outer space or vacuum, and obviously there will not be any gravity, the ball will hit on the object and it will reflect and travel straight line on the reflected direction, and it will go on till infinity until somebody blocks it. This is what the Newton's first law states, right? Okay, what it has to do with the light? The same way, when light hits on any objects and it will get reflected, and though we call it as light, it is not light, it's a bundle of photons. Thus photon has no mass, so earth gravity cannot do any major impact on its direction or its speed, so it start traveling in the straight line. Eventually it will hit on our retina. Once it hit on our retina, our brain will collect that information from retina and reconstruct it to be the object you are viewing. That's the reason if we enter into any dark room, we are not able to see anything, because there is no light source or photon to hit on the object and reflect it to our retina. One thing we can understand from this example, that the light behaves exactly like a ping pong ball, right? We have seen the previous example, because it has particle nature. Okay, if it has a particle nature and if it reflects exactly like a ping pong ball, then it will have a speed. If it has a speed, then it can travel certain distance. I will explain in this way. If the photon travels, then obviously the person who is standing very close to the reflected object will receive the signal light first, and the person standing far away from that particular object will receive it little later. This understanding can give us many surprising facts about our universe. Have a look at this following scenario. It has a light source, an object which is a counter, and person A and B. When the light is switched on, light travels from this source and hit on the target and reaches these people, person A and person B. Light can travel in the speed of 300,000 kilometers per second. In 1 second it can travel 300,000 kilometers. The amount of distance light can travel in 1 second is called 1 light second. Consider the object person A and person B are separated by a light second away from each other in a straight line, and the counter will constantly get incremented by 1 for every 1 second. Okay, in that case, once the light hit on the counter, person A or person B cannot see anything, because just now the light has hit the counter. But after a second, only person A will see number 1, not person B. He will still see no numbers. Meanwhile, our counter will increment every second. By this time, the counter will change to 2. Next second, counter will change to 3. Now the person B will see number 1 and person A will see number 2. This sequence will keep on going. Let's take this one more example. When number 100 comes in the counter, person A will see number 99, person B will see number 98, but a person X who is staying far away, who is 100 light years away from the source counter, will see number 1, because in 100 seconds the light has traveled 100 light seconds. That means the photon bounce back from the source will keep traveling in straight line until some interrupt happens. This chain of event will keep happening infinitely. What we are trying to understand, when a light hits on any object, it keep on traveling in the reflected direction as we seen it in the ping pong ball exercise. The distance light has traveled in 1 year is called 1 light year. Obviously, that is the unit we are using to measure the celestial bodies. Example, our nearby neighbor star Alpha Centauri, which is 4.37 light years away. That means if you travel in the speed of light, you will reach Alpha Centauri in 4.37 years. Okay, if somebody in Alpha Centauri right now taken the telescope and zooming us, and if he sees us right now, and they would probably see not me, the person who is standing here 4.37 years before. That's fascinating, right? Because light has taken that much time to travel and reach that Alpha Centauri. Let's come back to our dinosaur conundrum. There is a far galaxy which is called UGC 1382, Frankenstein galaxy, which is approximately 250 million light years away from our solar system. If you remember, I already mentioned that 250 million years ago, dinosaurs living in this earth. Obviously, in that case, our sun's photons might have hit on those dinosaurs and it could have reflected in the outer space. If it travels in the speed of light for 250 million years, by this time it could have reached our Frankenstein galaxy. You guessed it right. In case if somebody right now, intelligent life form or aliens, were trying to observe us right now, they probably may not see us. Instead of that, they would be seeing dinosaurs walking around on the earth right now. But what it has to do with me seeing the dinosaur? The title says, "Do our hopes lost seeing the live dinosaurs today?" Is it a misleading title? To find out, you may need to wait one more week. I'll be back.